Alright, so 31 says find f of g of x and g of f of x. Well, f of g of x is just f of g. And what's g? It's x squared plus 2. So now what does f say? F says whatever you got, you're going to multiply it by 4 and add 5. Okay, so whatever you got here, you're going to multiply it by 4 and add 5. And now it's just a matter of simplifying it. G circle f is g of f, and what's f? It's 4x plus 5, we know that. And what's g of this? G says whatever you got, you square it and add 2. So take this guy, square it, and add 2. When you multiply that out, you get this answer here. F circle f is f of f, and we know f is 4x plus 5. And remember, f says whatever you got, multiply it by 4 and add 5. So take this guy, multiply it by 4, and add 5. When you simplify, you get that answer. What about g of g? Well, g is x squared plus 2. Now g of x squared plus 2, remember g says square it and add 2. So take this guy and square it and add 2. Multiply all that out and simplify, and you get this guy here. 34, if you look at this graph on the left, on the right here, f of 0 is 0, so you put a 0 there, and g of 0 is 3. F of g of 2, well, 2, g of 2 is 5, and f of 5 is 4. F of 5 is 4. It's hard to see there on my graph, but that's what it is. 37, g of negative 2. Well, negative 2, g of negative 2 is just 1. And then g of 1 is 4. F of 4, that's f of 4. 1, 2, 3, 4. 4 is 2. 1, 2, 3, 4. 4 is 2. Sorry, right there. And what's f of 2? It's minus 2. So you always work from the inside out when you have a composite function. Figure out the inside and then figure out the outside. Now 47 says you get f is 2x plus 3 and g is 4x minus 1. So they want you to find f circle g, g circle f circle f, g circle g. So f circle g is f of g, and we know g is just 4x minus 1. Now what does f say? Multiply it by 2 and add 3. So multiply that guy by 2 and add 3. And you simplify and you get that guy. Now what's the domain? Well, you got the domain of f is everything. Domain of g is everything. So the domain of the two of them is everything. It's going to be the same thing for all of these guys. Alright, so g circle f is g of f. And we know f is 2x plus 3. Now what does g say? Multiply by 4 and subtract 1. So multiply by 4, subtract 1. And when you simplify, you get that. F circle f. F is 2x plus 3. Okay, so now what does f say? It says multiply by 2 and add 3. So take this guy and multiply it by 2 and add 3. When you simplify, you get that guy there. Now what's g of g? That's g of x. Well, g of x is 4x minus 1. Okay, now here we're going to take this guy, we're going to multiply it by 4 and subtract 1. So 4 times it minus 1. 50, f is cube root of x, and g is 1 over x cubed. So what's f circle g? That's f of g of x. Okay, and g we know is 1 over x cubed. Now what's f? F is the cube root of it, and it is 1 over x cubed. So the cube root of 1 is just 1, and the cube root of x cubed is just x, so that's 1 over x. Now what's your domain? You got to worry about dividing by 0, so throw out 0. What's g circle f? Well, remember f is the cube root of x. And what does g say? Whatever you got, you write 1 over it cubed. Well, here's your it. 1 over it cubed. Cube root cubed is just x. And again, you can't divide by 0. Now what's f? f of f, f is cube root of x. And what does f say? It says whatever you got, you cube root it. So we got this guy and we're going to cube root it. So you got the cube root of the cube root, which you actually multiply these two together and you got the ninth root. Okay? And your domain is everything because this is an odd root. G of g, that's g of 1 over x cubed. Now what does g say? It says whatever you got, it's 1 over it cubed. So 1 over it cubed. Well, 1 over x to the third times 1 over x to the 1 to the third times 1 over x to the third is 1 over x to the ninth. And since this is a complex fraction, you can flip the bottom and multiply it times the top and you get x to the ninth. Now you have to throw out 0 because the original function was dividing by x, and so you can't let x equal 0 there. (55). You get f is 2 over x and g is x over x plus 2. So what's f circled g is f of g, and what's g? X over x plus 2. And what does f say? 2 over it. Well, here's your it. 2 over it. Remember, that's a complex fraction, so you flip it and multiply until you get 2 times x plus 2 over x, which is 2x plus 4 over x. Now x cannot equal 0, and from the original function inside, x cannot equal negative 2. Now what's g circle f? Well, that's g of f. And what's f? 2 over x. Now what does g say? Whatever you got, you write it over it plus 2. Well, here's your it. It over it plus 2. Now the fastest way to clear out, simplify a complex fraction, is to multiply top and bottom by your common denominator, in this case x. So x times 2 over x is just 2. X times 2 over x is just 2. X times 2 is just 2x. So 2 over 2 plus x, you can cancel a 2 and you'll get 1 over 1 plus x. X can't equal negative 1 there, and from over here x cannot equal 0. So f circle f is f of f, and what's f? It's 2 over x. So now what does this say? F says whatever you got, it's 2 over it. So here's your it, and it's 2 over it. You flip and multiply and you get 2x over 2, which is just x. You can't be equal to 0 from the original function inside here. You can't let x equal 0. G of g, well, we know g is x over x plus 2. And now here, what do we do here? We say it is it over it plus 2. Well, here's your it. It over it plus 2. Multiply top by x plus 2 and the bottom by x plus 2 and you clear out your fractions. This guy times that, the x plus 2's cancel and you just get x. This times this one, your x plus 2's cancel and you just get x. And then 2 times that, you get 2x plus 4. Simplify everything and you get this guy. Solving the denominator tells you that x cannot equal 4/3. From the original question, x cannot equal negative 2. (57). Two more functions, 1 over the square root and x squared minus 4x. So it's f circled g, that's f of g, and what's g? X squared minus 4. Now what does f say? It says whatever you got, you write 1 over the square root of it. Here's your it, 1 over the square root of it. And that's your answer. Now how do you find your domain? You set what's underneath the radical greater than 0 and solve, and you got to do the number line dividing up, and you pick places where it's positive. So minus infinity to 0 and 4 to infinity. Notice we're not including the endpoints because we can't let it equal 0. It's in the denominator. G circle f. That's g of f. We know f is 1 over the square root, so just write 1 over f, 1 over the square root. Now what does g say? G says whatever you got, you square it and subtract 4 times it. Well, square it and subtract 4 times it. 1 over square root of x squared is 1 over x. 4 times 1 over square root of x is just 4 over square root of x. Now we can't let x be 0, and we got to let x be greater than 0, so strictly greater than 0 to infinity. What's f? F of f? That's f of f, and f is 1 over the square root of x. So f of 1 over the square root of x says 1 over the square root of x. That's really 1 over the 4th root of x. And when you flip and multiply, you get the 4th root of x. That's an even root, so you got to force it to be greater than or equal to 0, which would be 0 to infinity. But from here, you can't let x equal 0, so you throw out 0 and just strictly greater than 0 to infinity. G, circled G, is g of g, and we know g is x squared minus 4. Now what does g say? G says whatever you got, you square it and subtract 4 times it. Here's your it. You square it and subtract 4 times it. You multiply all that out and combine like terms and you get this guy. Now what's your domain? It's everything. There's no restrictions on your domain there. 61. 61 says here's f and here's g and here's h. They ask you to find f, circle g, circle h. Well, that's f of g of h. Work from the inside out. What's h? X minus 1. Now what do you do for g? You just square root it. So square root of x minus 1. What do you do for f? You take it and subtract 1. So it and subtract 1. F circle g circle h. Here's your h is square root. G says it minus 5, so square root minus 5. F says raise it to the 4th and add 1. Raise it to the 4th and add 1. Now 65 says here's your composite function. Find the original two functions. So if you let the inside be g, x minus 9, then the outside is just x to the 5th. And if you work your way backwards, you can see that that's correct. 69, if you let the inside be g, then the outside is just the absolute value of x. And 70, I wrote down two possible answers. You can let g be the square root of x, and then f is just the square root of 1 plus x. Or you could let g be 1 plus the square root of x, then f would just be the square root of x.